Hey guys, we are looking at a bunch of compound inequalities here. We are going to graph these and write the solutions in interval notation. Now you will notice on all these examples, my x is already alone. That is not always the case. If you have one where x isn't alone, you do need to get x alone before trying to graph these and write them in interval notation. Now, if you need an example, I will link a video in the corner for you. All right, so we have and inequalities, which you will see written like this or sometimes like this. We also have or inequalities. We treat them just a little bit differently, but I think it'll make sense. So for this one first, I am looking for a number that is greater than or equal to 12 and also less than 22. Well, there's a lot of numbers that fulfill that qualification, right? That sounded really fancy, but there's a lot of numbers that could fit in that range, right? So that is what interval notation will show me, is what numbers it includes to fulfill both of these. Because it's and, it needs to fulfill them both. So in graphing this, I need x to be greater than or equal to 12. So because it's greater than or equal to, I'm going to use a closed circle. And numbers greater than 12 go in this direction. I'm not going to do it all the way because I do want to see how 22 affects it. So my number needs to be greater than or equal to 12 and less than 22. It doesn't have the equal to sign, so I'm going to do an open circle. And less than is in this direction, and that is where they meet up. Now, a number over here, say like 0. 0 is less than 22, but it's not greater than or equal to 12, so that's why it's not included here. There are some people who may prefer to graph both the lines and then just look at where they overlap. If you like that better, go for it. I just kind of like this way. All right, so now I need to write this as a range of numbers that will work. So I'm saying, if someone's like, well, what number can I pick? I say you can pick any number between 12 and 22, but how do I show them that they can include 12 but not 22? Well, if the number can be included, I do a bracket. 12 is greater than or equal to 12, so it satisfies that one. It's also less than 22, so it satisfies that one. 22 has the open circle. It did not have the equal to, so I use a parenthesis because it's anything less than 22. 22 would work here, but it wouldn't work for this one, so it can't be in my solution set. So I use a parenthesis. That is the way I would show my answer. All right, that was an and inequality. Now let's go ahead and look at an or inequality. So again, my graph, I'm just going to do a nice little number line. 9, 14. You can do a more detailed number line, of course, if you want to, but you don't have to. So this one is an or. This means it needs to satisfy one of these. It doesn't have to satisfy both. It can, but it doesn't have to. So I need x to be less than 9. There's no equal to, so I'm going to use an open circle. X can be less than 9, or x can be greater than or equal to 14. So that direction, greater than 14. Because this is an or, I can pick a number in this range or this range. So how do I show that in interval notation? Well, I'm going to start with this one. It goes forever that way, literally. I could pick any number less than 9. I could pick negative 2 million, right? So how do I show that? Well, I'm going to use negative infinity. I can pick any number from negative infinity all the way up to 9. Now, it doesn't include 9 because of that open circle. There's no equal to, so I'm going to use a parenthesis. What about negative infinity? Well, guess what? Infinity and negative infinity always, every time, get a parenthesis. You should never see it with a bracket because negative infinity and infinity are actually just like ideas. They're not an actual number, right? Sorry if that broke your dreams. But that is how I show that part of my graph. But that's just for this one. I also need to show it can also be this. It needs to be this or this. So you can also pick a number from 14 all the way forever to infinity. Now, infinity always gets parentheses. 14, it's a closed circle. It had that equal to. It can be 14. So I'm going to use a bracket. Now, I want to show that these are together. They're not two separate answers. So what I'm going to do is put a U in the middle. It means union, like to satisfy this inequality, pick a number between here or between here. They're together. All right, there's that one. All right, hopping over here, we've got another OR inequality. So here is my number line. We've got -13 and -5. So I have got, hold on, let me grab a different color. Here we go. The first one says x is less than -13. So it's not supposed to equal -13. So I've got an open circle. And less than goes this way forever. So it needs to be less than -13 or less than or equal to -5. So it can be -5. So I'm going to do a closed circle. And then any number less than that. So we're going the same direction. That's still an open circle, but I am going to draw a little line for it because I could plug in through it. I should have said, because I could plug in -13 here. It doesn't work on this one, but it does work for this one. Now, because it's an OR inequality, guess what? All these numbers over here work for both, which is great. Right here, it only works for one of them, but that's okay because it's an OR inequality. So to satisfy this inequality, I can pick any number all the way from -infinity to -5. Parenthesis for -infinity, bracket for -5 because it does include -5. Woohoo! There's that one. All right, we've got another and. So here's my number line, 7, 15. So I am looking for numbers that are, hold on, orange. The numbers aren't orange. That are greater than or equal to 7. So it can be 7. So that way, and we're going this way. And greater than or equal to 15. So right here, it can be 15. And then continuing that way again. Well, you might be tempted to say, okay, pick any number from 7 to infinity, right? But this is an and inequality. It needs to satisfy both. So this is another scenario where it might be helpful to draw them as separate lines, if that helps you. But when I look at this range right here only satisfies this one, right? So 10's in here. 10 is not greater than or equal to 15. And because of that and, it needs to be. So this section here does not work for the and. So that means to satisfy both of these inequalities, I'm just looking from 15 on forever. So you can pick any number from 15 to infinity, and that will satisfy both of these. Now it can include 15 because of that closed circle, the equal to. Infinity always gets a parenthesis. All right, there's that. That's why it's so important to pay attention if it's and or, right? All right, this one is written like this, but this is an and inequality. This is just a different way you'll sometimes see it written. Me personally, this might be kind of weird, but my brain likes to see it like this a lot better. So sometimes I will rewrite these as and inequalities. It's the same thing, just shown a different way. So x is less than or equal to -2. This is an optional step. You don't have to do this. And x is greater than 5. All right. So let's do our number line. We've got -2 and 5. So I'm looking for a number that's less than or equal to -2 and also greater than 5. You might already be noticing that we are running into a bit of a problem. So let's see what to do with this. So x is less than or equal to -2. So it can be -2. So I'm going to do a closed circle. And less than is going in that direction. And x needs to be greater than 5. So open circle, because there's not an equal to, and greater than. All right, this is an and inequality. So I need to look at where the lines overlap. I'm not seeing any overlapping, right? And if we think about this just logically, is there any number that's less than or equal to -2 and also greater than 5? No, that number does not exist, right? So we would write no solution. And oftentimes the fancy way, I don't know if it's fancy, but that you'll see it written in interval notation is a circle with a line through it. There is no solution to this. If it were an or inequality, totally. And nope, there is no solution to that. All right, let's look at this one. We are graphing. This is another or. So we've got 0 and 6. X is greater than 0. So we put an open circle because there's no equal to. So greater than 0. I'm going to start writing it that direction, but I want to see how this one affects it. Or x is less than 6. So we're going to do an open circle and this way. All right, now I want us to think about this for a minute because up here, that's how we left it, right? But on this one, this is an or. So it just needs to satisfy one of these. So like, let's say 10. 10 is not less than 6, but it is greater than 0, and it only has to fulfill 1. So really, these lines, because it's an or, can keep going in both directions. Okay. There's not any number that won't satisfy one of these. Every number is either greater than 0 or less than 6. Every number, right? Again, if this were an and, we'd be in trouble. It's an or, so we're not. So we might write on this all real numbers would be a solution for this. Or interval notation, we say, hey, you pick any number you want between -infinity and infinity, and you got it. All right? These always get parentheses, and that would be my answer. All right, these are possibilities of different compound inequalities you will see. Like I said, sometimes x will not be alone. Make sure you get it alone first, and I will link some other examples if you need them. Thanks.